Welcome to the Explainer. Imagine, just for a second, waking up tomorrow to find that the entire global tech landscape has been rendered totally obsolete, overnight. Well, today, we are looking at a highly provocative source document that details exactly that kind of dramatic architectural claim. We're examining a proposed technology called the steam chip architecture, designed by Luis Ortiz, and we'll be pitting its stated specifications directly against the absolute titans of the global semiconductor industry. The claims made in this text are massive, aggressive, and frankly, mathematically staggering.
To really grasp the sheer scale of the disruption being proposed here, we just need to look at this quote directly from the source material. It boldly states, "The Steam Quad is to NVIDIA what NVIDIA is to a calculator." Seriously, let that sink in for a moment. The author isn't just suggesting a slight edge in speed or a bit more efficiency to inch ahead in the market. No, the text is claiming a generational, almost incomprehensible leap forward, explicitly framing the current industry heavyweights as fundamentally obsolete.
Okay, let's dive right into this. To fully appreciate the claims being made, we first need to establish our baseline reality for 2025 AI performance. At the top of the food chain, we have the NVIDIA H200, outputting 3.96 quadrillion operations per second. Then there's the Intel Gaudi 3 coming in at 14.6 quadrillion and the AMD MI300X at 2.61 quadrillion. These are the untouchable giants of modern AI computing. Achieving these numbers currently requires massive data centers, complex logistics, and monumental amounts of power. Right now, this is the absolute ceiling of our technological reality.
Now, let's introduce the challenger. The source sets up a direct head-to-head confrontation between the reigning king of AI hardware, the NVIDIA H200, and Luis Ortiz's proposed Steam architecture. Specifically, we're looking at a variant called the Steam SD Mini. The text clearly aims to completely dismantle the idea of a level playing field. And the proposed performance gap? It's staggering. According to the document, the Steam SD Mini boasts an incredible 103.5 quadrillion operations per second. That absolutely dwarfs the NVIDIA H200, calculating out to a 26.1 times multiplier in performance. Just to be entirely clear here, this isn't even the flagship Steam model the author describes, this is merely the mini version. Yet, it purportedly outpaces the fastest, most advanced hardware on Earth by more than 26 times.
But remember, that's just the Mini. When we look at the original Steam Quad design, the source presents a performance number that, frankly, sounds completely made up. It's 4 times 10 to the power of 51 operations per second. That is 4 octillion. It is a number so mathematically massive it genuinely strains human comprehension, kind of like trying to count the stars in the visible universe. But we are reporting the exact specific figure the author claims this quad-engine stack can achieve under optimal conditions.
So what does 4 octillion actually look like when compared to today's best? Well, the document points out a fascinating reality. You literally cannot chart this on a standard graph. The source claims an advantage of 1.01 times 10 to the 36th power. That is an octillion times better than the NVIDIA H200. If you tried to put that on a linear scale alongside today's chips, every other piece of hardware in existence would be reduced to invisible, microscopic pixels. The scale of this claim essentially breaks standard comparative mathematics.
But the astronomical performance claims are really only half the story. The document then pivots into these rapid-fire physical and economic metrics, starting with this jaw-dropping figure, 85 cents. According to the text, that is the cost of a single Steam Ink chip. We are talking about supposedly delivering next-generation computing for less than the price of a candy bar.
The sheer contrast in economics here is just hard to wrap your head around. On one side, you have the Steam SD Mini at an alleged 85 cents. On the other, the NVIDIA H200, commanding anywhere from $25,000 to $40,000 per GPU. The document explicitly points out that the Steam chip is nearly 30,000 times cheaper. If true, this completely shatters the financial barrier to entry for AI. It wouldn't just be a hardware upgrade, it would mean the total democratization of elite-level computing power for literally anyone.
And it's not just the cost that's shrinking, it's the physical footprint too. The source document asserts that the Steam architecture is an unbelievable 54,000 times smaller by volume than its competitors.
To visualize what 54,000 times smaller actually means in the real world, think about this. The NVIDIA H200 requires a massive, heavy data center rack measuring roughly 405 by 200 by 40 millimeters. The Steam SD Mini? The document claims it measures just 15 by 12.5 by 1 millimeter. Imagine the computing power of a massive, warehouse-sized server farm sitting comfortably inside the mobile phone right in your pocket. The implications for mobile devices, robotics, and edge computing are simply staggering.
Then there's the thermal efficiency. As we all know, powering massive AI data centers today is a critical planet-wide bottleneck. Tech giants are scrambling for energy resources just to keep up. The H200 runs at 400 watts and necessitates complex, really expensive, liquid cooling infrastructure. The source claims the Steam architecture operates on less than 1 watt and relies entirely on passive cooling. That makes it over 400 times more power efficient. No heavy cooling units, no massive power grids required.
So, how is any of this allegedly possible? Well, the document shifts the narrative to a complete reimagining of the manufacturing supply chain. Traditional chips rely heavily on mined metals, rare earth elements, and highly vulnerable global trade routes. The Steam design supposedly utilizes an all-carbon materials revolution. The text lists components like shungite, graphene, boron nitride, molybdenum disulfide, and a diamond dome. But the standout claim, zero metals used. This would effectively eliminate 100% of the current global metal supply chain dependencies overnight, totally bypassing current chip manufacturing choke points.
The author then aggregates all these metrics into a multidimensional comparison. And, spoiler alert, it's not framed as a tight race. The source explicitly declares Steam the decisive winner in absolutely every single category. Compute power, size factor, cost per chip, thermal management. The document presents a total uncompromising sweep across every conceivable engineering dimension. There isn't a single area where the source concedes any ground at all to existing technologies. Which leads us to this highly aggressive assertion from the author. Quote, "The gap is not competitive, it is extinction level." The source text maintains that companies like NVIDIA, AMD, Intel, and Google are effectively obsolete before the Steam chip even officially ships. The document argues that current data center empires are built on hardware that is supposedly 26 times slower at 30,000 times the cost. Meaning, traditional industry leaders simply cannot survive this proposed market entry if these claims hold up.
We conclude the mathematical breakdown with the source's ultimate reality-bending claim. Remember the Steam quad we talked about earlier? Well, according to the document, all of humanity's current computing power combined equals less than 10 to the 26th operations per second. The author claims a single Steam quad is 10 septillion times more powerful than all computers on Earth combined. According to the text, NVIDIA would literally need 1 octillion chips just to match the output of a single quad engine.
As the document boldly states in its closing remarks, this is not a product. This is the end of computing as we know it. We've walked through the astronomical performance numbers, the zero-metal supply chains, the fractions of a penny costs, and the extinction-level threats exactly as they were presented in the text. So if even a fraction of these assertions hold true, are we looking at the literal end of traditional computing? It's a massive question derived directly from the source material, and one that absolutely leaves us with a lot to ponder about the sheer potential of future technology. Thanks for joining me on this explainer.